intercepts, be able to show the test point and how you figured out which region it was, so there will be a place for you to be able to get that one done. This is an interesting problem because as an 8, or I think this is an 8, this one's an 8-point problem, you get points for whether the line is in the right place, and you get points for whether you shaded the right side of the graph. So if your line is correctly positioned, but you forgot to shade, you only get half credit. If your line is incorrectly positioned, but you shaded the correct side of the line, then you get half credit. You only get full credit if you did everything right in a problem. You'll have one linear system to graph and shade. So that's kind of this last stuff up here, linear inequalities and linear systems. There's one problem with that. There's a problem like this. The linear system's a little bit more point value because you got 2 lines, and that means you get points for each of the lines being in the right place. If one's in the right place, one's in the wrong place, you at least get some of the credit for that, and then having the correct shaded region, you get points for that. So you get a lot of partial credit in there if we can see what you did on paper. But if there's nothing on paper, then it's either right or wrong based upon what you see in the program. Now, we don't count it totally wrong or totally right. And I have to go back and look and see, did they put the line in the right place? And did they shade the right region to be able to give you the partial credit out there? So support that on paper. That would be a good thing. And then there will be one full-blown linear programming problem. That's what we talk about today. And we'll talk about Wednesday as well, because it'll catch all of you before you take the test, very likely. The workbook pages on linear programming are not the same as these two. Those are the very last 2 pages in the workbook, and I would suggest that you might want to bring those on Wednesday, because on Wednesday what we may do is we may use those as our examples for the problems that we're going to go through linear programming, and we're going to go through that today. That linear programming problem that you are going to see on your test is a 16-point problem. It has 5 specific individual steps that we're going to expect to see, and we're going to get a chance to go through 2 or 3 of them today, depending upon our time frame of the problem, and that will be our total dedication for what's going to be on Wednesday. Those 2 workbook pages will not be due until Monday, giving you plenty of time to be able to practice them still if you don't take your test until Thursday. I could make them due Wednesday, but Monday's good enough for me. So that last week, next week, we have no lab hours that are required. We can spend all of our time in the lab doing the practice tests, or those 3 practice quizzes for the test, final exam prep quizzes. So I'm looking at 11 problems probably on the test, and this is pretty much going to be the composition. The big ticket problems are right here. Being able to multiply a system by hand, and being able to do the linear programming problem. Those are the big ticket problems. I have had students in the past that have walked out of the test with a 100%. And when the partial credit was assigned to the problem, they got a 68%. Because they showed no steps for solving the system by hand. They showed no steps for doing the multiplication of matrices by hand. And they showed no steps for the linear programming problem. I'm telling you, if those 3 problems are not supported, right or wrong, you're losing all the points for the problem. So it's not me, it's the powers that be that tell me that I have to be the SOB bad guy down here. So I'm going to be the totally bad guy with that, okay? So let's look at what we have to deal with. Let's give it an idea of our concept problem in here. Linear programming concentrates on the applications of graphing linear inequality. So it's going to touch here as constraints or restrictions, finding the feasible region, which involves linear systems and graphing and the shading section of the problem, determining a point that will allow an objective function to have a minimum or a maximum. This is the new stuff. This is the part that we haven't talked about yet today. That's the only new thing that we're going to be exposed to. So being able to graph solve a system, shade, and one new topic out here. It's a 5-step process, and as a 5-step process, this is what you're probably going to be expected to do and what you're going to get points for on your test. Number 1, we're going to expect you to be able to set up, because it's going to be a word-based problem, set up, transfer from the word problem into a chart that helps you organize the information. We had to do that in linear inequalities. We had to do that in augmented matrices, and they're coming back now. Page 2 of the workbook pages you just got back, those are the type of problems that we did linear equations in, where we use a chart method. We're going to be using the same chart method here. You're going to want to identify the unknowns. You want to know where the variables are. You're going to want to get the totals in the right place. For the table that you set up, that's 3 of the 16 points for the problem. You're going to be expected to identify the objective function early in the problem, but it's not going to be used until late in the problem. That's new. You're going to be expected to be able to identify all the constraints that might be present, or in other words, to write the system of equations with the additional conditions that have to be met to be able to limit it to being in the first quadrant. So these, the setup of the table is 3 points, the objective function is 2 points, and the identifying the constraints is 3 points. There's 8 of the 16 points just for being able to set the problem up right. Any part of those that's missing, it's a problem. Graph the system. Determine what the feasible region is, which region you're supposed to shade. Determine the corner points of each of those regions. That's 5 points of the 16 points. And then use your objective function to be able to find out where the minimum or maximum is going to occur. That's going to be the remaining 3 points. Now what's new to us here is this part of the problem. So when we look at doing minimum or maximum values, a minimum or a maximum value will always occur at a corner point of your feasible region. So if you don't get the right feasible region, you have no chance of being able to come up with the correct maximum or minimum. So it's all the points of the problem that we're going through in the exercise. So the best thing to do would be to walk you through one problem of a particular type so that you can see it. These notes are already posted up into the compiled notes that you can print before you come to class. So here's